Hello, my dear students. Welcome to Unacademy GATE English channel. How many are there? Those who are coming new to this channel, please share the channel, subscribe the channel. Share the channel, subscribe the channel. Those who are coming new, share the channel and subscribe the channel. Let me introduce myself. Myself, KV Swamy. I did my MTech in Systems and Signal Processing from JNTU College of Engineering, Hyderabad, and passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching my favorite subjects, signals and systems and communication systems throughout the country. And total, I have 12 plus years of teaching experience. And in this teaching experience, many of my students got single and double digit rank many times. And now I'm associated with Unacademy. And if you want to take any subscription in Unacademy, you can use my code. Any course if you want to purchase, you can use my code KVS Live and you'll be getting flat 10% discount on the price. Now let's observe what are the available packages in Unacademy for GATE and ESE. Coming to that, so we have two types of packages here, namely Plus subscription and Iconic subscription. This Plus subscription is nothing but the subset of Iconic subscription, in the sense that all the facilities which are available for Plus subscription, they are also available for Iconic subscription, but there are some additional advantages with Iconic subscription. Before going to see that, let's see what are available in Plus subscription. Here in Plus, a student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are held in English and Hindi. If a student is not comfortable with Hindi, he can listen the batch in Hindi, and if a student is not comfortable in Hindi, he can listen the class in English from different educators. Many educators are available for each subject, and we have something known as rank improvement batches also. Now apart from this, we have one more package known as Iconic subscription, in which the student will be under the supervision of a experienced educator known as mentor. Mentor who will be regularly monitoring the progress of the student. So in Iconic, we can say that the student is having a personal coach and a detailed study planner is given to the student. Study booster sessions we are going to have, personalized test analysis, dedicated doubt clearing instructors will be there, and preparatory study material is also given. Now you can ask one thing, what are the prices for Plus and Iconic subscription? Suppose if you are going for Plus subscription, say Plus subscription, 1 year subscription, if we are going to take, if you are going to have, it costs around 27,225 rupees only. And if you are going to use the code KVS Live, you'll be getting flat 10% discount on the course. Suppose if you are going for 18 months course, that is 1.5 year course, this in Plus it costs around 34,650, and if you are going to use the code KVS Live, you are going to get 10% flat subscription. Again, good evening. Again, if you are going for 2 years course, I mean in Plus it costs around 39,600. Again, if you are going to use the code KVS Live, flat 10% discount you are going to get. Means 24 months 2 years course comes around 35,000 to 36,000. So 2 years course. So this is very beneficial for second year students. This 24 months course is very beneficial for second year students. Now coming to the next subscription called Iconic subscription, in which the student will be under the supervision of a experienced educator known as mentor. So here for 12 months, that is 1 year, so it costs around 45,225 rupees. And if you are going to use the code KVS Live, you will be getting flat 10% discount. Again, for a 2 year course, 2 years, it costs around Iconic 66,600. And again, if you are going to use the code KVS Live, flat 10% discount you are going to get. So you can choose your own plan. And if you want to take a subscription, don't hesitate to use the code KVS live to get flat 10% discount on either Plus or Iconic. Okay, right. Now let's get back to our discussion. Yesterday, students, if you remember, I'm able to see very few students. See, those who are coming new, please subscribe the channel, share the channel in many ways. Subscribe the channel and share the channel, right? Because we are going to have many initiatives also here in this channel, Unacademy GATE English. Many initiatives are going to come. Will reveal slowly, right? Now, coming to the discussion, yesterday I gave you a detailed blueprint of the subject signals and systems. What are the topics which we are going to cover, and I gave you the number of hours I'll be taking also. So this is the time to start the subject. Now let's start the subject. So let me put what is the topic: basics of signals and systems. And let me tell you that before starting, those who are having zero knowledge on the subject, they can happily come and enjoy the class. No prerequisites are required. Only addition, subtraction, multiplication, divisions, trigonometric identities, and small differentiations and integrations are prerequisite. Anybody can listen, because we are going to discuss everything from the scratch. Everything from the scratch. Okay, good evening, Suri. Okay, fine. So basics of signals and systems. Basics of signals and systems is the first unit. What are the basics? This is a very important unit. If you can understand this unit, rest of the units are just applications of the first unit, students. And again, before going to start, students, I'm going to say, please subscribe the channel and share the channel and inform this. Inform that Unacademy GATE English is coming with many initiatives. Okay, right. So the first and foremost definition here is, how do we define a signal? How do we define a signal? How do we define a signal? Two types of definition I'm going to give. First of all, basic definition anybody can understand. That is, signal is a physical quantity. We define signal as a physical quantity carrying some amount of information. Carrying some amount of information. If anybody asks you, what is the definition of a signal? You must reply it as, signal is a physical quantity carrying some amount of information. What is present in a signal? Information is present in a signal. So based on that available information in the signal, we can make some decisions. Now, what are the day-to-day examples we can give for a signal? Example, you are reading a newspaper. In the morning, you are reading a newspaper, or you are going through a channel. You have some information about stock exchange. Stock exchange. Now, in the stock exchange, they'll give a signal like this. As the day is progressing, how the market is going to rise or how the market is going to fall, right? This kind of signals generally appear in newspapers. So this is a signal which carries some amount of information about stock exchange. Based on this information, we can plan whether to buy a share or sell a share, right? Because information is present in that. See, one more example what I can give is, recently elections were held in our country. Suppose if a political party wants to analyze how many MP seats they have won compared to the previous years. Elections came in the year 2004. A particular political party got 64 Lok Sabha seats. Again, after 5-year term, elections came in the year 2009. The same political party got 75 Lok Sabha seats. Elections came in the year 2013. This dropped down to 41. Again, elections came after 5-year term. Elections came in the year 2018. So again, they got some 84 Lok Sabha seats. So Based on this is also a signal which carries some information about the performance of a political party. So based on this, the political party can take some decision on their performance, right? So signal is a physical quantity carrying some amount of information. This definition you must know, basic definition. Signal is a physical quantity carrying some amount of information, right? Suppose if a heart patient is there, generally doctors will examine his ECG. So that is a signal which carries some information about the position of the heart. Okay, earthquake happened in Indonesia. We are going to record the intensity of earthquake on a Richter scale. So that is a signal which carries some amount of information about the intensity of earthquake. Suppose I want to read how many babies were born in Hyderabad in today. So that is a signal which carries some amount of information. I want to know how many COVID patients are there. I mean, how many COVID patients are there in Hyderabad today. So that is a signal which carries some amount of information. So we define signal as a physical quantity carrying some amount of information. Now, after knowing the definition, we'll see how many types of signals exist in nature and what are the signals relevant to us. Means what are the signals which we are going to study as far as any competitive exam is concerned. Till now we know only the definition. Other than definition, we don't know anything, right? Now let me go back to the next slide. Right background, let me take the black background. Now how you are going to classify the signals? In the first slide we have seen the definition of a signal. That signal is a physical quantity carrying some amount of information. Observe here, my dear students. These signals are classified. How we are going to classify these signals? These signals are classified or categorized based on something known as dimension. How we are going to classify signals? Based on dimension, which stands for an independent variable. Which stands for an independent variable. What is this dimension? What is this independent variable, and what is the role of this independent variable in a signal we are going to discuss. We know only the definition that signal is a physical quantity carrying some amount of information, and I am going to classify these signals based on dimensions. How you are going to classify based on dimensions? One-dimensional signals, because signals are classified based on dimension. So two-dimensional signals I am going to classify. Two-dimensional signals, three-dimensional signals, three-dimensional signals, four-dimensional signals, and so on. Four-dimensional signals and so on. Enough. Now coming to the first classification called one-dimensional signals. Here the name itself signifies dimension stands for an independent variable. And remember, my dear students, that one-dimensional signals are those signals which are having only one independent variable. One-dimensional signals are those signals which are having one independent variable. What are the examples you can give for a one-dimensional signal? An audio signal, what we are listening daily, or a voltage signal or a current signal. An audio signal or a voltage signal or a current signal can be given as an example for one-dimensional signal, where we are going to represent the signal like this, f of t. In order to represent this signal, what we'll be doing? We'll be taking one vertical axis and we'll be taking one horizontal axis. Along the horizontal axis, always we are going to represent the independent variable, and along the vertical axis we are going to represent the dependent variable. Dependent variable means dependent on this one. And remember, independent variable means it is the quantity of a signal. Independent variable means it is the quantity of a signal which we can vary. Independent variable means it is the quantity of a signal which we can vary. Here we can give different values of t along horizontal axis, and we can record the values along vertical axis. This independent variable and dependent variable, they have got some functional relationship. so that as we are going to give different values of t along horizontal axis, we are going to get the values along vertical axis. So an audio signal can be represented like, right? One-dimensional signals. One-dimensional signals means one independent variable. Coming to the next classification called two-dimensional signals. How many independent variables we can have? These are the signals which are having two independent variables. How many independent variables? Two independent variables. What are the examples you can give for a two-dimensional signal? An image, what we are storing in a computer or mobile, can be given as an example for two-dimensional signal, where we are going to represent it as f of x comma y, where x and y, here x and y are known as spatial coordinates. What are these known as? Spatial coordinates. Remember, my dear students, that independent variable need not be time always. It can be time, it can be space, it can be frequency, it can be anything based on the application. An image, a two-dimensional signal, can be represented like this. We are going to take the spatial coordinate x along horizontal axis and spatial coordinate y along vertical axis. And what I said, independent variable is the quantity of a signal which we can vary. In the case of one-dimensional signals, what happened? We are having only one independent variable, so that as we are going to vary the value of t along horizontal axis, we can record the values along vertical axis. In the case of two-dimensional signals, what happened? How many independent variables we are going to have? Two independent variables, means you can vary the value of x as well as you can vary the value of y also. Now, in the case of image, if I take any point, in the case of image, if I take any point, some p of x comma y, which represent brightness or contrast. The image brightness is dependent on the spatial coordinates x and y. X and y. So this is about two-dimensional signals. So one-dimensional signals are having one independent variable, whereas two-dimensional signals are having two independent variables. Now coming to three-dimensional signals, you can easily answer. How many independent variables we can have? Three independent variables. How many independent variables? Three independent variables. The best example for three-dimensional signal, what you can give is a black and white TV picture. I don't know how many of you have seen black and white TV picture. So it can be given as an example of three-dimensional signal. Three-dimensional signal means moving picture. Suppose if I take two-dimensional signal, an image, f of x comma y. F of x comma y represent what? Brightness. Now this is a still picture. No, say two-dimensional signal is a still picture. It is not in motion. If brightness or contrast varies with the time, so three independent moving picture, three independent variable, three-dimensional signal. Now again, my dear students, coming to four-dimensional signals, how many independent variables we can expect? You can easily answer four independent variables. Four-dimensional signals, four independent variables. What are the examples you can give? The temperature. Suppose if you want to record the temperature at a point in a room, we know that any point in space can be represented with three coordinates x, y, z, and temperature varies from time to time. So four independent variables, four-dimensional signal. My dear students, if you observe this temperature at a point in a room, this black and white TV picture, this image or this audio signal, they all carry some information, right? Information is present, and so we define signal T carrying some amount of information. Signal is a physical quantity carrying some amount of information. Now look here, my dear students. Now what is the definition of signal I gave you? Again, go back to the previous slide. Signal is a physical quantity carrying with information. Now can I change the definition of a signal? Now what I want to do is, I want to define the signal like this. Signal is a, from the very basics we are going to discuss. Signal is a physical quantity carrying information and can vary with one or more independent variables. Yes or no? One or more independent variables. So a signal can have one independent variable or more number of independent variables. This is the second definition of signal, the same definition, but just I'm extending the definition by including independent variables. Signal is a physical quantity carrying information and can vary with one or more independent variables. Right? Hope everybody understood. Right. Now, one good news is that as far as any competitive exam is concerned, like GATE, IES or any public sector undertakings, my dear students, we are having only one dimensional signals in our curriculum, in which we have only one independent variable. We have only one dimensional signals in which we have only one independent variable. We are not concerned with two-dimensional signals, three-dimensional signals or multi-dimensional signals. You need not bother about multi-dimensional signals. Our focus, our entire focus is towards one-dimensional signals only, in which we have only one independent variable. But if you know the concepts of one-dimensional signals well, you can extend the same to the rest of the classifications. Say you are getting a single integral here, one-dimensional signal, single integral. You will be getting a double integral here. You will be getting a triple integral here. Assume that you have one-dimensional Fourier transform. You will be having two-dimensional Fourier transform here. You will be having three-dimensional Fourier transform here. So knowing the concepts of one-dimensional signals is very much essential. Right? Now what I am going to do is, let's see the classification of one-dimensional signals, because for GATE or ESE we are concerned only with one-dimensional signals in which we have only one independent variable. Our focus is towards the signals which are having only one independent variable. Right? So again I want to repeat, my dear students, first of all, we define signal as a physical quantity carrying some amount of information, and we classified signals based on dimension, which stands for an independent variable, and we have seen some cases and we came to a point that for competitive exams we are having only one dimensional signals in which we have only one independent variable. Right. Now what is the next topic? Observe here. See, now what I want to do is, I want to classify these one-dimensional signals, because I came to a point that for competitive exams, now we have to play with these signals. We are concerned only with one-dimensional signals. One-dimensional signals means, remember my dear students, one independent variable and one dependent variable. One independent variable and one dependent variable we are going to have. Now these one-dimensional signals taking time as independent variable can be classified into three types. First one is continuous time signals. Very, very important classification, my dear students. Continuous time signals. Second one is discrete time signals. Continuous time signals. Second one is discrete time signals. And the third one is digital signals. What are these continuous time signals, discrete time signals, digital signals, and what are their interrelationships? We are going to discuss now. Coming to the first category called continuous time signals. Remember, in order to represent continuous time signals, we are going to take one vertical axis and one horizontal axis. Along the horizontal axis, we are going to represent the independent variable, because one dimensional signal means only one independent variable. And remember, in the case of continuous time signal, your independent variable happens to be t. Continuous time signal, independent variable happens to be t. And the dependent variable means dependent on this one is taken along vertical axis, denoted by some f of t. Now, this is a continuous time signal. If this is a continuous time signal, what is the definition of continuous time signal you are going to give? Can you define continuous time signal? Yes, I can define a continuous time signal like this. Observe here, my dear students. Continuous time signals are those signals which are present throughout the continuous time period. Continuous time signals are those signals which are present throughout the continuous time period. In the sense, the signal is defined at 0, it has some value. The signal is defined at 1, it has some value. The signal is defined at 2, it has some value. The signal is defined at 3, it has some value. Instead, the signal is also defined at 0.5. Defined at 0.5 means it has some value. The signal is also defined at 1.5. The signal is defined at 2.5. The signal is defined at 3.5. Instead, the signal is also defined at 0.01. The signal is defined at 1.01. The signal is defined at 2.01, 3.01. Or if you can break the interval from 1 to 2 into 1 crore parts, each part will have some value. If you can divide the interval from 1 to 2 into 1 crore parts, each part will have some value. That is the definition of continuous time signals. Continuous time signals are those signals which are present throughout the continuous time period. You can say that continuous time signals, remember my dear students, continuous time signals are those signals which are present throughout the continuous time period. Means the signal is defined at every instant of time. 0.1 you take, 0.2 you take, 1.1 you take, any instant of time, the signal can have some value. Continuous time signals are those signals which are present throughout the continuous time period. After knowing the definition, let's see what is the nature of this independent variable and what is the nature of this dependent variable in the case of continuous time signals. The independent variable, what we are going to consider here is time. Independent variable, what we are going to consider is time, and the dependent variable forms your amplitude. Dependent variable forms your amplitude. Basics are very, very important, my dear students. If you can follow the first unit, rest of the units are very simple for you. And share this information among your friends. Now, what is the nature of independent variable and what is the nature of dependent variable? For that, again, go back to the definition of continuous time signals. Continuous time signals are those signals which are present throughout the continuous time period. Means the signal can be defined at every instant of time. Or in short, we can say that the independent variable is continuous. Independent variable is what? Continuous. Continuous means independent variable can take any value. Continuous means independent variable can take any value. Coming to the dependent variable, which is nothing but your amplitude. Any amplitude you can have, my dear students. At 0, you can expect an amplitude of 2.5. At 1, you can expect an amplitude of 2.52. Any amplitude you can have. Means dependent variable, vertical axis, this can also take any value. Means it is also continuous. My dear students, both independent and dependent variables in the case of continuous time signals, they can take any value. So they are continuous. Now, after looking at the definition, the nature of independent and dependent variables, the next thing is what are the examples you can give for a continuous time signal, right? I can give a signal represented of the form. You might have seen this signal. A signal represented of the form f of t is equal to e power minus t u of t. E power minus t u of t, which we call by the name decaying exponential. What is the name we give for this one? Decaying exponential. Decaying exponential. What is this e power minus t? What is this u of t? What is their multiplication? Why the signal came like this, we are going to discuss in future. But for the time being, this signal can be taken as an example of continuous time signal which is defined at every instant of time, which is defined at every instant of time. So important point to remember is that continuous time signals exist at every instant of time, and continuous time signals fall under the category of one-dimensional signals, my dear students. Now after that, let's come to the next classification of signals, discrete time signals. In order to represent these discrete time signals also, we are going to take one vertical axis and one horizontal axis. Here also, in the case of discrete time signals, the independent variable is taken along horizontal axis, but it is denoted by n. Instead of t, we are going to denote it by n. T is a representation for independent variable in the case of continuous time signals. N is the representation for independent variable in the case of discrete time signals, my dear students. Now, and the dependent variable is taken along vertical axis denoted by f of n, denoted by f of n. Now how you are going to represent a discrete time signal? Observe here, observe here. This is the representation of a discrete time signal. This is the representation of a discrete time signal. Now if this is a discrete time signal, what is the definition of discrete time signal you are going to give? Remember, my dear students, that discrete time signals are those signals which are present only at discrete instance of time, not at every instant of time. They are present only at discrete instance of time. Discrete time signals are those signals which are present only at discrete instance of time. By looking at that signal only, you can notice that. Or simply I can modify the definition like this. Discrete time signals are those signals which are present only at integer values of time. This is a very powerful definition. Discrete time signals are those signals which are present only at integer values of time. Now you can observe here, the signal is defined at 0, it has some value. The signal is defined at 1, it has some value. The signal is defined at 2, it has some value. Signal is defined at 3, it has some value. But no signal is defined at 0.5 as in the case of continuous time signals. No signals defined at 1.25 as in the case of continuous time signals. No signals defined at 2.75 as in the case of continuous time signals. Or we can say that these discrete time signals are absent at fractional values of time, but they are present only at integer values of time. Discrete time signals are absent at fractional values of time, but they are present only at integer values of time. That is the definition. Now after that, we'll see what is the nature of this independent variable. My dear students, those who are coming, you must put your attendance by clicking the like button. You must put your attendance by clicking the like button. Come on, you must put your attendance and you must share this session also. Right. Now, after knowing the definition of discrete time signals, here also we'll see what is the nature of this independent variable and what is the nature of this dependent variable in the case of discrete time signal. The independent variable what you are going to take here is also time, and the dependent variable forms your amplitude. Right. Again, my dear students, what is the definition of a discrete time signal? Discrete time signals are those signals which are present only at integer values of time. If this signal would have existed at every instant of time, as in the case of continuous time signals, we would have said that the independent variable is continuous, but the signal exists only at integer values of time. So we are going to say independent variable is discrete, not continuous. Independent variable is discrete. Coming to the dependent variable, which is nothing but an amplitude. Any amplitude you can have, as in the case of continuous time signals. Means at 0 you can expect an amplitude of 2.5, 1.7, any amplitude you can have. Means dependent variable is still continuous. Dependent variable is still continuous in the case of discrete time signals, right? Now, after knowing the definition and the nature of independent and dependent variables, the next thing is what are the examples you can give for a discrete time signal. Remember, my dear students, that discrete time signals are represented as sequences. What I'm saying, discrete time signals are represented as sequences where we follow this notation. Discrete time signals are represented as sequences where we follow this notation f of n. For discrete time signals, we are going to use this square brackets like this. For continuous, this kind of brackets. Discrete time signals are represented as sequences where we'll follow this notation: curly braces open, 1, -2, 1.5, some 3. This kind of representation we are going to use. This is known as sequence, and we are going to place arrow here, arrow, where arrow indicates the sample value at n is equal to 0. To the right side of arrow are n is equal to 1, n is equal to 2, n is equal to 3 integer values. To the left side of arrow are n is equal to -1, n is equal to -2 kind of things. In order to represent this discrete time signal, what we are going to do is take the independent variable n. Now 0, 1, 2, -1, -2. Observe here. What is the value at 0? 1.5. The dependent variable can be continuous. Give a sufficient amplitude of 1.5 in the upward direction. What is the value at 1? 3. Give a sufficient amplitude of 3 in the upward direction. And my dear students, while putting discrete time, so you have to put dots here. In the tops, you have to put dots. These must be like matchsticks, but you should not put like this. If you are representing like this, means it has different meaning. This is a different signal. So you have to put like this only. You have to put dots on the tops. Right, but this is correct, this is wrong representation, discrete time, right? Now what is the value at -1? -2 in the upward downward direction. Take a sufficient amplitude. And what is the value at -2? 1. This is the representation of a discrete time signal. Discrete time signals are represented as sequences. And one important point to remember here is that in exam, if this arrow is given, well and good. If this arrow is given, well and good. If arrow is not given, by default you must take the arrow at the first point. Remember, my dear students, if arrow is not given, by default you must take the arrow at the first point. If arrow is given, no problem. If arrow is not given, you must take the arrow at the first point. Okay, this is the representation of a discrete time signal. Discrete time signals are represented as sequences. Now coming again to this tree, after knowing the definition of continuous time signals which exist at every instant of time and discrete time signals which exist only at integer values of time, we must see, is there any functional relationship that exists between continuous time signals and discrete time signals? Yes, by a process known as sampling, continuous time signals are converted into discrete time signals. My dear students, if anybody asks you what the relationship between continuous time signals and discrete time signals means, you must say it as sampling is the relationship that exists between continuous time signals and discrete time signals. Anyway, we are having separate unit on sampling, separate unit dedicated to sampling. But here in a nutshell, we'll see how this sampling process is done. Observe here, my dear students. The sampling operation, which is nothing but the relationship between continuous time signals and discrete time signals, is nothing but a switch operation. Remember, sampling operation is nothing but a switch operation, where the nature of the switch is the switch will be closed only at particular instance of time, not at every instant of time. It will be closed only at particular instance of time given by t is equal to nts. At the input of the sampler, we are going to give the continuous time signal x of t, and at the output of the sampler, we are going to collect the discrete time signal denoted by x of nts. Always remember, my dear students, that Sampling operation means independent variable t in a continuous time signal simply replace with NTS. Very important. Sampling operation means independent variable t in a continuous time signal simply replace with NTS, where this TS is known as sampling period. TS is known as what? Sampling period, which is nothing but distance between adjacent samples in a discrete time signal. This is a sampling period. Sampling period means distance between adjacent samples in a discrete time signal. The distance between adjacent samples is known as a sampling period. For example, I'm going to feed this kind of signal. X of t is equal to e power minus t u of t. The shape of the signal is available here only, which is a decaying exponential. Now I am going to feed this signal as the input to the sampler. Now what will happen? Let's observe. What I said, sampling operation means independent variable t replace with NTS. So wherever you have t, simply replace with NTS. I'm having t here, t here, t here. So replace with NTS. X of NTS is equal to e power minus NTS u of NTS. Suppose if I select the TS value to be 1 second. If I select the TS value to be 1 second, or the distance between adjacent samples to be 1 second, I'm going to get a discrete time signal. Remember, TS must be 1 second. Now what happens in that case? X of n is equal to e power minus n u of n, where n can take only integer values. Now in order to draw this signal, take the independent variable n. Now the independent variable is n. Can take integer values 0, 1, 2, 3 and so on. What happens if I substitute n is equal to 0? If I substitute n is equal to 0 and put here, e power 0 is what, my dear students? It is 1. What happens if I substitute n is equal to 1? E power minus 1. E power minus 1 is a value less than 1. What happens if I put n is equal to 2, the next integer value? I'll get a value less than the previous value. What happens if I put n is equal to 3? I'll get a value still less than the previous value. In this way, and so on. In this way, a continuous time signal is converted into a discrete time signal by a process known as sampling. Sampling operation means for the time being independent variable t replaced with NTS. What is the physical significance of sampling? How we are going to multiply impulse train and all we'll discuss separately. But for the time being, you remember that sampling operation means independent variable t replaced with NTS. Okay, this is about discrete time signal. Now let's go back to the previous slide. So we have seen continuous time signals and we have seen discrete time signals. Continuous time signals means they exist at every instant of time, whereas discrete time signals means they exist only at integer values of time. Continuous time signals, independent and dependent variable, they can take any value though they are continuous. Discrete time signals, independent variable is discrete, it cannot take continuous values, but dependent variable is continuous. The relationship between continuous time signals and discrete time signals is sampling. The next part what I'm going to discuss is not there for electrical students, but you can listen, okay, because the digital signals classification is not there for electrical students, but you can listen. Only definitions we are going to say here. Observe here. After getting a discrete time signal from a continuous time signal by a process known as sampling, what is the nature of this discrete time signal? Independent variable is discretized. You observe with sampling, independent variable got discretized, but dependent variable is still continuous. And we know that if we want to process any signal on a computer understands only in the language of ones and zeros. Now our aim is to convert these continuous amplitudes. In discrete case to discrete amplitudes. What is my aim now? I want to convert this continuous amplitudes in discrete case to discrete amplitudes, which is done by a process known as quantization. Discrete time signals are converted into digital signals. By a process known as quantization, Discrete time signals are converted into digital signals. Quantization means rounding off. Remember, my dear students, for the time being, quantization means rounding off. Means suppose if I have a value of 2.5, which is a continuous one, I can round it to 2 or I can round it to 3 so that I can give the binary representation. After encoding, there will be one more process known as encoding, with which we are going to give the binary representation. Right? So can you tell me what is the nature of independent variable and what is the nature of dependent variable in the case of discrete? Type your answer in the chat box. What is the nature of independent variable and what is the nature of dependent variable in the case of digital signals? My dear students, those who are listening, please type your answers in the chat box. Type your answers in the chat box. Both are discrete. Both are discrete. Both will be discrete. So here in the case of digital signals, this dependent variable, they can take only integer values. They can take only integer values. Right? Discrete. Very good. JN442. Very good. Or I can say one thing, that these digital signals are nothing but discrete time signals only. Digital signals are nothing but discrete time signals only, but with amplitude quantized. Digital signals are nothing but discrete time signals only, but with amplitude quantized. With amplitude quantized. Only in the last unit, that is discrete Fourier transform, we are going to consider this digital signals. Until last unit, we'll be discussing continuous time signals and discrete time signals only. So this is the classification, my dear students. Continuous time signals, discrete time signals and digital signals. Suppose if I ask you one question, that if I want to discretize the dependent variable, I must go for what operation? If I want to discretize the dependent variable, I must go for what operation, my dear students? Discretizing the dependent variable. If anybody asks you how to discretize the dependent variable in a signal, you must say quantization. If I want to discretize the independent variable, to what operation I must go for? Sampling is the operation. If you want to discretize the independent variable, go for sampling. If you want to discretize the dependent variable, go for quantization. Go for quantization. Right. Now, this is about the classification of one-dimensional signals. Okay. Right. Now, the next concept, some students are saying that we are unable to see. Okay. Right. I won't be writing on the back of myself. Okay. I didn't notice that. Right. The next thing is, can you tell me, my dear students, what is the independent variable in the case of continuous time signals? Time. And what is the independent variable in the case of discrete time signals? Time, but integer values of time. So independent variable plays a major role in the case of one-dimensional signals. So the next topic, what we are going to discuss is very important topic, transformations of the independent variable. If any student is sleeping now, you can get up. Very important, transformations of the independent variable. You must put a separate book for this subject, because we are going to discuss many things, minimum 100 to 200 papers book you must put. Transformations of the independent variable. Transformations of the independent variable. What transformations we can perform on the independent variable of a given one-dimensional signal, we are going to discuss. Basically, there are three transformations, my dear students. They are listed like this. First one is time shifting operation. Time shifting operation. Time shifting. Second one is time reversal. Time reversal operation. time reversal operation. Third one is time scaling operation. Time scaling operation. So these are the three transformations of the independent variable we are going to perform for continuous as well as discrete time signals. Time shifting, time reversal, and time scaling, my dear students. Now, how you are going to define this time shifting, time reversal, and time scaling? Let's observe. The first one, time shifting. Time shifting operation. Right. How we are going to define? Observe here. Very, very important topic, my dear students. Very, very important topic. Listen carefully. See, if x of t represents your original continuous time signal, first of all, I'm talking about continuous time signals. Continuous time signal representation is this one only, right? If x of t represents my original continuous time signal, then its time shifted version is denoted by x of t minus t naught. T minus t naught. So this is the original signal, this is shifted version. Two cases arise. What happens if t naught is positive? What happens if t naught is negative? Remember, my dear students, that if t naught happens to be positive, the resulting signal, what we are going to get will be a delayed version of the original signal. Delayed version of the original signal. Whereas if t naught happens to be negative, the resulting signal, what we are going to get will be an advanced version of the original signal. Advanced version of the original signal. T naught positive means delayed version. T naught negative means advanced version. Sir, can you explain with an example? Yes, I can explain with an example. Suppose if you are given a continuous time signal like this. Continuous time signal. What is the definition of continuous time signal? They exist at every instant of time. Every instant of time. From this, I must get what is x of t minus 1, and I must get what is x of t not visible, right? Again, I've written here. So let me erase x of t. And go back to the next slide. Right. Observe. So this is my x of t. So this is a signal given x of t. From this, each and every basic with analysis we are going to discuss. X of t is given. We are now how to get what is x of t minus 1 and x of t plus 1. Always remember, my dear students, whenever you are given a transformation of the independent variable, always compare with the standard shift. Always compare with the standard shift. Now, if I compare with the standard shift, what will happen? What is the value of t naught here? T naught value is what? 1. Means positive or negative? Positive. Now go back. If t naught happens to be positive, the resulting signal must be a delayed version of the original signal. Delayed version of the original signal. Actually, your original signal must start at 0. Your original signal must start at 0. Instead, the resulting signal is delayed by 1 unit. Delayed by 1 unit so that it will start at a point called 1. So that it will start at a point called 1. This is x of t minus 1. Actually, original signal has to start at 0. Instead, the resulting signal will be delayed by 1 unit so that it will start at a point called 1. Now, in the same way, if you want to get x of t plus 1, if I compare with the standard shift, what is the value of t naught? T naught will be minus 1. Positive or negative? Negative. Go back to the previous slide. If you observe, if t naught happens to be negative, the resulting signal must be an advanced version of the original signal. Advanced version means actually our original signal has to start at 0. Instead, the resulting signal will be advanced by 1 unit so that it will start at a point called minus 1. Minus 1. Right? Now, can you say anything from these examples? Yes. Now, can I say that here delay means right shift, advance means left shift? Delay means right shifting the signal. Advance means left shifting the signal. Can I say that? Yes or no? Yes. So here, my dear students, delay means right shift. Simply right shift. Delay means right shift. Advance means left shift. Delay means right shift. Advance means left shift. Then what about discrete time signals? The same definition holds good in the case of discrete time signals also, that if x of n represents your original discrete time signal, then its time shifted version is denoted by x of n minus n naught. Discrete time signal, x of n minus n naught. If n naught happens to be positive, the resulting signal will be delayed version. If n naught happens to be negative, the resulting signal will be advanced version. Now, can you give any example for discrete time signal? Yes. See, when we are learning remember my dear students, when you are learning the subject, we have to do many experiments we have to perform. Observe here. Given x of n is equal to this one, 3, 4, 5. Already I told you, discrete time signals means they exist only at integer values of time and they are represented as sequences. And what is the significance of arrow? Arrow indicates the sample value at n is equal to 0. If arrow is not given, by default you must take the arrow at the first point. Now x of n is given. From this get what is x of n minus 1 and what is x of n plus 1. You have to calculate both. First of all, first task is drawing the signal. Continuous time signal shape is given. Here sequence is given. How to draw? First point, we know that arrow indicates the sample value at n is equal to 0. So right side of arrow 1, 2. Left side of arrow minus 1, minus 2. Now how to represent this discrete time signal? Take the independent variable. Independent variable is represented along horizontal axis. Discrete time signal means only integer values of time it will exist. Now what is the value at 0? 5. Give a sufficient amplitude of 5 in the upward direction. What is the value at 1? 4. Give a sufficient amplitude of 4. This is 5, this is 4. What is the value at 2? 3. What is the value at minus 1? Again 4. What is the value at minus 2? 3 again. So in this way we are going to represent a discrete time signal. First task is completed. X of n. Hope everybody is comfortable. Hope everybody is comfortable in drawing the discrete time signal. Please respond. Hope everybody is comfortable in drawing a discrete time signal, because we are going to discuss many advanced things. For that, drawing a signal is very, very important. Now, x of n minus 1. X of n minus 1. X of n minus 1 means compare with the standard shift. This is in the form of x of n minus n naught, where the value of n naught is what? 1. Means positive. If n naught is positive, the resulting, yes, exactly. If n naught is positive, the resulting signal what you are going to get will be a delayed version of the original signal. Means here delayed means what I told you, right shift. Right shift by how many units, my dear students? 2 units. Sorry, right shift by 1 unit, x of n minus 1. Now what happens if I right shift? An important point is going to come. All of you must wait. Important point is going to come. So here minus 2, minus 1, 0, 1, 2, 3 and my independent variable is n. Now x of n minus 1 means simply right shift. Right shift by 1 unit means this sample, the sample at minus 2 will come to minus 1. Minus 1, the sample at minus 1 will come to 0. 0 sample will come to 1. 1 sample will come to 2. 2 sample will come to 3. That will be the signal. Now this will be the shape. 3, 4, 5, 4, 3. Whatever may be the exam, if you are perfect with basics, definitely you can answer any question you can answer. Now this is x of n minus 1. Now can you write this x of n in terms of a sequence? Yes, I can write. How you can write? 3, 4, 5, 4, 3 with the arrow placed at what point? With the arrow placed at 4. The arrow placed at 4. Previously in x of n, where was the arrow? At 5. Because arrow indicates the sample value at n is equal to 0. Now where is the arrow? Now arrow is at 4. Arrow is at 4. Right. In the same way, if I want to get x of n plus 1, again this is in the form of compare with the standard shift. This is in the form of x of n minus n naught, where the value of n naught is what, my dear students? Minus 1. Positive or negative? Negative. If n naught happens to be negative, the resulting signal must be an advanced version of the original signal. Advanced version means left shift, left shift. So -3, -2, -1, 0, 1, 2, 3. Now left shift means what? Now the original signal is shifted to the left. The original signal is shifted to the left by how many units? 1 unit, 1 unit. So it will come like this. 3, 4, 5, 4, 3. 3, 4, 5, 4, 3. Now can you write this in terms of a sequence? Yes, I can write. X of n plus 1 is equal to how much, my dear students? The same, 3, 4, 5, 4, 3, but only the position of the arrow will change. Now where I must keep the arrow? Where I must keep the arrow? At 4 here. At 4. Yes or no? I must keep the arrow at 4 here. Now x of n is what? Our x of n is this one. 3, 4, 5, 4, 3 with the arrow placed at 0. Right? Now look here, I can say that given x of n, here this is x of n, my dear students. If you want to get x of n minus 1 delayed version, if you want to get the delayed version, move the arrow to the left. My dear students, if you want to delay, move the arrow to the left by 1 unit. If you want to advance, move the arrow to the right by 1 unit. Move the arrow to the right by 1 unit. So based on this analogy, if I ask you what could be x of n minus 2, all of you, right, you must write in your notebooks. What is x of n minus 2? X of n minus 2 means delay by how many units? 2 units. So I must move the arrow to the left. Delay means move the arrow to the left. Advance means move the arrow to the right. By how many units? Here 2 units. So the original signal is this one, 3, 4, 5, 4, 3. Now the original arrow position is here. Now delay now. So move the arrow to the left. This one. Hope everybody is comfortable. In the same way, my dear students, if I ask you what could be x of n minus 3, n minus 3 means I must move the arrow to the left by how many units? 3 units. But if I move the arrow in the original signal, if I move the arrow, this is 3 units, what will happen? This is the first point, second point, third point, nothing is there. Nothing is there means in discrete you can represent with a 0. So it becomes 0, 3, 4, 5, 4, 3, my dear students. Where you have to put the arrow? At 0. Nothing is there means you can represent with a 0. In a similar fashion, if I ask you what could be x of n plus 3, what could be x of n plus 3, my dear students? 3, 4, 5, 4, 3. Earlier in the original signal arrow is at 5. Now advancement means you must shift the arrow to the right by how many units? 3 units. First unit, second unit, nothing is there means you have to put. Hope everybody is comfortable. My dear students. So this is regarding the first transformation of the independent variable called time shifting operation. My dear student. So let me recap what we studied so that for the next class, it will be easier for you, because many things we are just at time shifting, time reversal we have to see, time scaling we have to see, combination of transformations, different examples we have to see, but already time is 8:05. So let me revise all it. See today, observe here, my dear students, and I want more number of students tomorrow. Inform your friends. All your doubts will be clarified. Each and every gate questions will be solved in the class only. Okay, more number of students, more number of initiatives in Unacademy Gate English channel. Right. Now today what we did, first of all I started my discussion with the definition of a signal. That signal is a physical quantity carrying some amount of information. After that we classified signals based on dimension, which stands for an independent variable, and we have seen examples for each case. Okay, and we came to a point that for competitive exams we are having only one-dimensional signals, and after that we classified one-dimensional signals as we classified one-dimensional signals into continuous time, discrete time, digital. Continuous time signals means they exist at every instant of time, and in the case of continuous time signals, both independent and dependent variable, they can take any value, so they are continuous. Discrete time signals means they exist only at integer values of time, and in the case of discrete time signals, independent variable is discrete but dependent variable can be continuous, my dear students. And the relationship between continuous time signals and discrete time signals is sampling. Sampling operation means independent variable t replaced with nts, and discrete time signals are represented as sequences where the arrow indicates the sample value at n is equal to 0. In exams, if arrow is not given, by default you must take the arrow at the first point. Okay, after that, by a process known as quantization, that is rounding off, we got the digital signal from discrete time signal. If you want to get a digital signal, first of all from continuous time signal, it must be discretized first, then quantization must be done. And in the case of digital signals, both independent and dependent variables, they are discrete. Okay, and after that we were looking at the transformations of the independent variable. So first one is time shifting. So x of t minus t naught, if t naught or n naught, x of n for discrete, x of n minus n naught, if t naught or n naught happens to be positive, delayed version, if t naught or n naught happens to be negative, advanced version. Okay, delay means right shift, advance means left shift. So we have taken these examples. Hope you are comfortable with the examples and practice many examples. And tomorrow coming up tomorrow, we are going to discuss the time reversal in detail, time scaling, which is very important transformation of the independent variable in detail. And after that, if possible, we'll solve some previous gate questions. And what happens if you are given combination of transformations, shifting, reversal, or shifting and scaling in one transformation, if you are given, how to perform, and what are the various methods, and what are the various shortcuts we have, and what are the various observations we are going to see, we'll discuss. Okay, that's all for today's class. But tomorrow crowd must be in, I want a huge crowd, my dear students, and inform that Unacademy Gate English channel is going to bring many initiatives, and we are going to discuss each and every basics of signals and systems or communication, any subject, my dear students, right? So this is about today's class. And before winding, you can follow me. See, myself, KV Swamy, I told you my introduction, and you can follow me on unacademy.com @KV Swamy, and please subscribe to this Telegram channel, Unacademy Gate English. This is no more Gate Telugu now. It is Gate English now. Okay, please subscribe to get the updates. You'll have a lot of quizzes, and you can ask your doubts in this Unacademy channel. And let me give my number: 83099444245. This is my number. So if you're having any doubts, or if you want to take subscription, you can contact me through WhatsApp to this number, 83099444245. And these are the number of channels what we are having in Unacademy. Creatrix, EECEIN, Unacademy. This is regarding the mechanical and production engineering. This is chemical and civil, computer science. Unacademy Gate questions. This is computer science channel. This is our channel, Unacademy Gate English. You have to subscribe, and you have to make your friends also subscribe, and lot of initiatives are going to come. You can enjoy each and every subject in a easier way. And electrical junction we are going to have, and apti express we are going to have. Okay, my dear students, and thanks you for your time, and I want a huge crowd tomorrow. Okay, so thank you. Tomorrow we'll meet.